Now we're going to take a look at the client-based SSL VPN. We're going to see what are the requirements, what is the reason, how does it work, and then we're going to go to the implementation side on the ASA firewall. So client-based SSL VPN, what is the use case? In general, it is used for enterprise-owned devices. So like you're going to fire up a client-based SSL VPN session back to the headquarters from a company-owned device, because the client-based SSL VPN requires a VPN client software to be installed, and it can happen that if you want not a user, which not an employee, to fire up an SSL VPN session. So if you want a contractor to be able to fire up on a VPN session so they can access some of the resources from back to headquarters from the protected network, then because that let's say third party is of course employed to another company, that company may have a policy which states we don't allow the installment of any clients on our computers if they are not authorized by our internal policies. So for that reason, in general, it could happen that if you want somebody to fire up an SSL VPN session, but that somebody is not an employer, it's a third party person, it can happen that they don't have the rights to install the VPN client. So in that use case, you're going to see that they're going to use the clientless SSL VPN session. But from corporate owned devices in general, you're going to fire up a client based SSL VPN tunnel. Also, once the VPN client software is being installed, in general, client profiles are also deployed. So what is a client profile? Like in the old Cisco VPN client, which was used to fire up IV1 IPsec remote access sessions, this was the PCF file. So it's nothing else but the configuration of the VPN client software, which tells the VPN client software how to run the SSL VPN tunnel, where to connect, which certificates to use if you use a certificate-based authentication, which username and passwords to use. So it's a configuration of the AnyConnect VPN client software, nothing else. But with the AnyConnect, the client profile is going to be in an XML format. Now, the benefits of client-based SSL VPN is that it provides full support for all IP applications. As you're going to see, clientless SSL VPNs have some restrictions because there's no client installed on the remote access user. And it provides support for real-time applications and DTLS, where clientless does not. Now let's see what is the traffic flow. When we fire up the client-based SSL VPN tunnel, when the tunnel is being successfully built, what is the traffic flow, the data plane traffic flow to the tunnel? In client-based SSL VPNs, the remote client is going to be assigned or allocated an IP address by the VPN gateway, and that IP address is going to get assigned on the AnyConnect client NIC card. So when you install any kind of VPN client software, doesn't matter if it's Cisco AnyConnect or the old Cisco VPN client or whatever clients, they install a virtual NIC card in there, which is going to be used by that computer to fire up the VPN tunnel, to get an IP address from the VPN gateway, and to know which traffic to be sent to the VPN tunnel. So that's how the VPN client, doesn't matter if it's SSL VPN client or IPsec VPN client, is going to know what traffic to route in the IPsec or SSL VPN tunnel, because it's going to have that NIC card installed, the virtual NIC card installed in there, which is going to route packets, specific packets, to the IPsec or to the SSL VPN tunnel. So on the protected network, traffic is going to be seen to be sourced from the AnyConnect IP address. So what happens if the remote client sends traffic through the SSL tunnel, and it's going to source that from the AnyConnect IP address, which was leased, of course, from the VPN gateway. And the ASA decrypts the traffic and routes it further on the protected network. So what this means, if you look at our use case in here, if this is the VPN gateway, ASA3, and PCA is the remote access client, and let's suppose that the public IP addresses, so the ASA3 has in here an address of 136.1.37.16, And let's say that the client has an address, likewise a public one, because the transport is going to be the internet of 172.16. Although this is not public, let's assume that 172.16.96.100. So when the tunnel is being built, in the negotiation in the control plane part, the ASA is going to lease to the client an IP address. That IP address is going to be assigned by the client to its virtual NIC of the VPN client software. So let's assume that the VPN gateway is going to assign to this PCA an address of, let's say, 10.10.10.10. This is the AnyConnect address assigned by the gateway of 10.10.10.10. So once the tunnel is up, it means we're going to have that secure bidirectional TLS or SSL or DTLS tunnel. Doesn't matter what that kind of tunnel is. Let's put in here the SSL or TLS tunnel. So when the remote access client wants to access protected resources, which is like, for example, router 4, because remember, like, this is the border of the network in here. So what's on the left side is going to be the internal network. What's on the right side is going to be the public network, which is going to be the internet. So through that SSL VPN tunnel, the client wants to access resources protected by the VPN gateway, which is going to be, for example, something like router 4, to manage router 4. So how the packet is going to look like, what his PCA is going to send in that tunnel. So if it's a telnet session, it's going to be, I'm going to put in here the payload, whatever the payload is. It's going to be the telnet traffic, the payload. And then this PCA wants to access router 4, let's say on the address of 136, payload, on the address of 136, or on the loopback on 10.4.4.4, for example, let's say. So this is what the user is going to initiate: an IP packet sourced from 10.10.10.10 from its AnyConnect IP address leased by the gateway, destined to 10.4.4.4. Of course, I'm not going to put in the TCP header as well, so just the IP header. Source is going to be 10.10.10.10. And destination is going to be 10.4.4.4. And then this goes in the SSL VPN tunnel, which means it's going to get encapsulated into TCP or UDP, so TLS or DTLS. And of course, it's going to be secured. So whatever is going to be contained in here is going to be encrypted and secured, not going to be visible in clear text in the transit network. So it's going to be the TCP and TLS headers. And then we put in here the IP addresses of the VPN, of the SSL VPN gateways. So source is going to be PCA, which is 172.16, the public address of PCA, 96.100. And destination is going to be the VPN gateway's address, which is 136.1.37.16. So whatever is everything which is in here above the TCP or TLS, it is secured, encrypted, hashed. It is not readable in clear text. So this is what the ASA, the VPN gateway, is going to receive. This packet is going to, of course, remove the IP header, remove the TCP TLS headers, decrypt the packet, and then this is what the ASA is going to route further in the network. So the router 4 is going to see a telnet session coming in from 10.10.10.10 from the address of the AnyConnect client on the remote access client. So that's why, for this reason, client-based SSL VPNs provide full support of any IP applications, because the client remote access client has a VPN client software, and it's going to have an IP address assigned to send traffic in the SSL or SSL or TLS tunnel. Now, from the configuration point of view, we're gonna configure SSL VPN tunnel client-based with the ASA firewall being the VPN gateway. So the configuration steps are going to follow up on pretty much on what we stated before of how TLS SSL works. So because the ASA is the VPN gateway, it needs a certificate. Then of course we have to enable client-based SSL VPN on the ASA. We have to configure the ASA to lease addresses to remote access clients. So the AnyConnect client is going to require an IP address to be assigned by the VPN gateway. Configure split tunneling policy. So now what this means, you have, like in the case of IPsec VPNs, remote access, you have two options: split tunnel all or split tunnel specifically. So when the SSL tunnel is being built, split tunneling is exactly what it states it's going to do. The VPN gateway is going to control, is going to push over to the client what traffic to be sent to the SSL VPN tunnel. So you may want PCA to send traffic in the tunnel only if it's destined to a specific subnet like 10.4.4.4. Maybe the single scope of this SSL tunneler from that user's point of view is to manage that device, for example. So this is split tunneling policy where the gateway, the VPN gateway, tells the client to send traffic in the SSL or TLS tunnel only if it's destined to 10.4.4/32. That's split tunneling in there. So when PCA wants to access the internet, he's going to send that traffic directly over in the internet, not in the SSL VPN tunnel. But you can also configure a split tunneling policy, the split tunneling policy to be tunnel all, which means that user, all IP traffic being sent from that remote access user is going to be sent to the SSL VPN tunnel. So also traffic destined to 10.4.4.4 for management, for managing that specific device, and also, for example, internet traffic. So the user is going to send also internet traffic in the SSL VPN gateway, in the SSL VPN tunnel, and then if the ASA configuration allows that, the ASA is going to route the packet, is going to decrypt it, and then route the packet in clear text out on the internet again. Then we have to configure on the ASA what I call the connection profile tunnel group, which we're going to speak about this in a couple, but that the connection profile, as the name states, is the profile of connection. How do the users connect? So the connection profile is a container which controls the pre-login settings of the SSL or TLS session. And then configure the group policy, which is going to be containing the post-login settings, which means once the tunnel is up, what traffic can the user send to the tunnel? What is your authorization, for example? And configure reverse route injection, because as we said before in here, if the ASA has leased to the VPN, to the AnyConnect client, an address of 10.10.10.10, it means that, as I said before, when PCA is going to send traffic in the SSL VPN tunnel, it's going to source it from 10.10.10.10. So router 4 is going to receive a telnet session sourced from 10.10.10.10, destined to 10.4.4.4.4. And of course, router 4 has to be able to route the packets back to the client, which means router 4 needs a route for this 10.10.10.10. That's reverse route injection being performed by the VPN gateway. So the VPN gateway, because it has leased those addresses to the clients, it needs to advertise in the routing protocol on the inside network those IPs which it has leased to the remote access clients. Because otherwise router 4 is not going to have a route to route packets back to the remote access clients of 10.10.10.10. Let's take it one by one now. So certificate provisioning, we have a couple of options. We can use the self-signed certificate, which means we can use the built-in one, the temporary self-signed certificate, or we can let's say configure the SA. We can provision the SA with a persistent self-signed certificate, which is user configured, of course, by yourself. And the main difference between those two, temporary and persistent, because both of them are self-signed, again stays in the name of the feature. The persistent one is going to be persistent across reboots. The temporary one is going to change dynamically after an ASA reboot. So of course, in general, it's not good to use a self-signed certificate. It's of course recommended to use a certificate on the SA which is issued by a trusted CA. But if you use the self-signed one, at least use the permanent one so it doesn't change across reboots in there. Or of course, you can use a certificate issued by a trusted CA, which is recommended, which means we have to enroll with a CA, trust point configuration, and then configure the trust point to be used for SSL VPN connections. Then activating the SSL VPN capability on the SA for client-based SSL VPN sessions. We just enable SSL on the ASA interface, and we specify the AnyConnect image to be used and enable AnyConnect connections as well. To specify the AnyConnect image to be used by all SSL VPN sessions terminated on the SA, you need to have the AnyConnect client installed on the flash of the SA. And there's different versions for different operating systems. So if your remote access clients are both Linux and Mac and Windows computers, you're going to have one client for each of those 3 operating systems, which you need to copy on ESA Flash and install them to be used by ESA for AnyConnect connections. Then authorization attributes, which means we have to configure the address assignment. The VPN gateway has to assign an address to the AnyConnect client. And options are via DHCP, locally on the ASA or remotely, or via local IPv4 IPv6 pool, or you can do per user static IP assignment if you authenticate the AnyConnect clients using the local database of users of the ASA. And then a speed tunneling policy. So once the tunnel is up, what traffic is going to be injected to the SSL VPN tunnel? As I said, by default, all traffic is being injected to the SSL VPN tunnel all policy. If you don't want that to happen, then you have to configure what traffic to be sent to the SSL VPN tunnel. Split tunneling configuration, and that's being done through an access list. Then those are only authorization attributes, but we have to apply those somewhere. That's going to be under the group policy, which contains, as I said before, post-login settings. So once the VPN session is up, then how do we we need to control what traffic is being sent in that tunnel and how it's being sent. So group policy authorizes the SSL VPN session. So we have to configure the group policy and then bind the speed tunneling policy to the group policy. So before we just configure the attributes, the authorization attributes, but we have to bind those together in the container which authorizes the SSL VPN session, which is going to be the group policy. And also bind the IP address pool. But the address pool can also be attached to the tunnel group. It's not a discussion depending on the design and what you want to achieve. In some cases, it's good to put it under the tunnel group. In some cases, under the group policy. So the IP address pool. Assuming, of course, you use a local pool to assign addresses to AnyConnect clients. Now, optionally, the default group policy, which is named DFLT GRP policy, can be used. Is not recommended. We speak in more details about this on the CCNP class. The connection profile, so which is going to control the pre-login settings. It's also known as tunnel group from the CLI. So in the ASDM in the GUI is going to show up as a connection profile, but in the CLI part is going to show up as a tunnel group. So that it controls the requirements to build the tunnel, and the most important one for the scope of the CCNA exam is going to be the client authentication method. So you're going to configure the connection profile and specify in there, okay, once clients are going to get connected and they're going to connect to this connection profile, then how do I want to authenticate those clients? And as you said before, you have a lot of options: certificate based, username password based, combination of both of them, or a certificate and multiple usernames and passwords. So you have to configure the connection profile, specify the authentication method, or we can choose the default one, which is the local user database. That's going to be our use case. And then, of course, bind the group policy to the connection profile. So similarly, the connection profile controls the settings required for the tunnel to come up. And once we've done that, which means those clients have been connected to that connection profile, then how do we authorize that SSL VPN session? Which it makes sense that we have to bind to the connection profile the group policy. And of course, in the group policy, we bind the actual authorization attributes like split tunneling policy and IP addressing information. Likewise, we have a default connection profile, which can be used. It's called default web VPN group. Is likewise not recommended. We speak in more details about this in the CCNP class of SIMOS, which is for the VPN class from the CCNP blueprint. So then the authentication and reverse auto injection. So we're going to have to authenticate the user, and we're going to use username password configuration using the local database. So we're going to create on the ASA a local username and password used to authenticate the AnyConnect clients. Option, of course, we can authenticate AnyConnect clients via remote, radius, LDAP, or Active Directory server. Now, ASA does RRI, reverse route injection, by default for SSL connections, which means that once the ASA has assigned to an AnyConnect client session an IP address of 10.10.10.10, for example, it is going to automatically install a static route as a host route, as a /32 for that assigned address. So in the use case that I showed you before, it means that the ASA, once the tunnel is up, is going to automatically inject a 10.10.10/32 static route in its routing table. So the last thing we want to do is, of course, we want to redistribute that static route into our IGP or BGP, depending what is the routing protocol the ASA runs. Because as I stated, otherwise, when router 4 receives a session to the SSL VPN tunnel sourced from the AnyConnect address of 10.10.10.10, so to the SSL VPN tunnel, router 4 receives an IP packet sourced from that source. It has to be able to route packets back to 10.10.10.10, which means if in our network in here, in the internal network, our routing protocol is whatever, RIP, EIGRP, OSPF, doesn't matter what it is. If the routing protocol is, let's say, RIP, we have to go on the ASA and redistribute those static routes into RIP, so that ASA3 is going to send via RIP an update about 10.10.10/32. So router 4 knows that in order to reach that 10.10.10, I gotta send packets to the ASA, and then the ASA knows that that 10.10.10.10 has been assigned to that specific remote access client, who's gonna route the packets in the tunnel back to the AnyConnect client. On the client side, it's more simpler. Of course, it can be complex as well, but for the CCNA exam, we just install the AnyConnect client on the remote access PC. Optionally, it can be downloaded from the ASA web portal upon first connection. And once the client has got installed, we configure the VPN gateway as the IP address or fully qualified domain name and connect. So you're going to go on the client, put in there the IP address or the fully qualified domain name of the VPN gateway, click connect, and if conversion is correct on both the ASA, we're going to connect to the proper connection profile, get authenticated, get an IP address, tunnel comes up, we receive the split tunneling policy, and then we're going to send all traffic or partial traffic to the SSL VPN tunnel. Verification wise, on the ASA, we can go in the monitoring tab via ASDM to verify the SSL VPN session state, or at the CLI level is the same command as in the case of IPsec VPN. Show me the VPN session database, show me the details, but only for the AnyConnect sessions.